This is a getting started guide to working with two-sided projects in the software. We're going to start by looking at a brief introduction to the process and concepts of two-sided machining, and then demonstrate the process of creating a two-sided project in the software. So what is two-sided machining? This is where you use the same piece of material to cut one set of toolpaths on one side. You'd then flip the material over, cut another set of toolpaths on the other side to ultimately create a two-sided part. And so for this to work correctly, it's essential to have exact alignment between the top and bottom sides of the material. So how can we create a two-sided part in the software? We have the ability to create double-sided projects in the same session. And depending on what software you are using, we can create and import vectors and components on either side of your part. You're able to visualize the two sides in a multi-sided environment in both the 2D and the 3D view, giving you the reassurance that everything is in the correct place. So how do we set our part up for two-sided machining? So when you first fire up the software and create a new file, you're going to want to choose to create a double-sided job. This will then put the software into a two-sided environment, where you would then go on to specify your job size. Then you're going to set your Z0 position for both sides, where you could set the Z0 off the material surface for both sides, off the machine bed for both sides, or you could opt to choose to zero off the same face. Now there is no right or wrong way to set this, but I prefer to set the Z0 off the same side, where the top side is on the material surface and the bottom side is on the machine bed. This way it ensures that the Z is always referenced from the same face of your material. Now it's very important here to accurately measure the thickness of your material. Something you may want to do if your material isn't particularly flat is to surface the top side so that you have a good reference face when you flip the part over. Then you'll go on to set the XY0 position. And finally, you will then choose the flip direction, and this is the way that you will flip the material over on your machine to machine the other side. And the flip direction influences the positioning of the vectors and models if you're using vcarve or Aspire, so that the geometry on each side is created in the appropriate positions relative to the opposite side. So let's have a look at the typical workflow of creating a two-sided part. So now that you have the part set up in the software, and depending on what software you are using, you can create or import vectors and components independently on either side of the material. And you can copy and move data to the other side too, where the software will position the geometry in the appropriate positions relative to the opposite side. So you never really need to worry that your data is misaligned, as the software automatically positions and aligns data that you send to the other side for you. And using the multi-sided view, you can prove your data positions in both the 2D and the 3D view to help you to visualize your two-sided part. Then you'd go on to calculate the appropriate toolpaths for both the top and the bottom side, where you can preview the toolpaths in a multi-sided environment for accuracy. Then once you're satisfied with your preview, you can save out the toolpaths for both sides and then set up your part on your machine to run the top and bottom set of toolpaths. So how do we physically align the XY location of the material when we flip the part over? The method we're going to talk about uses dowel holes to help us align the XY location when we turn the part over. So here you can see a picture of the top side of our part, and there is a hole that we've cut for the dowel. Here is a sacrifice sheet on our machine, and you can see we've machined two dowel holes in there, inserted the dowels, and now when we flip the part over, it should locate correctly on those two locations. Now there's two ways to approach this. So method one is to drill all the way through your material and straight into your spoil board. Method 2 is to drill partially through the material using asymmetric dowel hole positions. So let's have a look at both of these methods. So method 1. When you're cutting the top side of your job, you'll want to machine all the way through the part and into the spoil board and use the same XY0 position for both sets of toolpaths. If you are going to do that, you need to have a symmetrical hole pattern so that the positions are in the same location when you flip it over. And so you just need to remember which way you physically flip your material over on the CNC. And finally, you also need to make sure that when you are doing this, that you cut both the top and bottom sides in the same session of machining on your CNC. This method wouldn't allow you to stop the CNC and switch it off unless you could very accurately position the XY0 to the same location. But to get around that, we do have another option, which is method 2. So rather than drilling all the way through the material and into the spoil board, we'd look at using the asymmetric dowel hole method, where we drill part the way into the top side of the material and in a separate operation machine dowel holes into the spoil board. So let's have a look at how we'd approach this in the software and on our machine. So in the software, in your job, you're going to insert dowel vectors in a non-symmetrical pattern surrounding the part, and you're going to take those dowel vectors and you're going to copy them to the other side. Then, using the dowel hole vectors for the top side, we're going to drill partially through the top side of our material. Once machining is complete for the top side, we can now take that material off of the spoil board and we're completely done with the top side of our part. And so when it comes to machining the bottom side, you're going to set your XY0 position and your Z0 position for the bottom side on the spoil board. And the first toolpath that you're going to run is the dowel holes of the bottom side straight in to the spoil board. Then you're going to insert the dowels into those new dowel holes that we've just put into our sacrificial sheet. And now you can flip the top side material over, locating the part using those dowels. And now we can go ahead and machine the bottom side of the part, knowing that everything is located accurately in terms of their X and Y positions. And so there are a couple of benefits to this. One, it allows us to use a non-symmetrical hole pattern because we're going to be able to reverse that pattern and machine it into the spoil board when we flip the part over. And it's nice to use a non-symmetrical pattern because we can then ensure that when we flip our material that we only have one way that we could possibly relocate it onto our machine surface. And so this eliminates the fact that we might flip the part in the wrong direction to what we set in the software. And the other benefit is that I don't need to run the toolpaths concurrently maintaining the XY0 position between the top and the bottom. I could cut the top side on one day, and with this drill pattern machined on the top side for the dowels, I can then take the material off, I could run other jobs, I could turn the CNC off and then come back to it at a later date. And when I finally come around to running the other side, then the first operation on that day would be to machine the dowel holes of the bottom side on the job into the spoil board. Then I know I'm going to accurately locate what I machined first and then machine all of the other toolpaths for the bottom side, and I know that everything will line up correctly. And so the process that I've described here does require me to have a sacrifice sheet on the bed of my CNC in order for me to machine the dowel holes into. Now, if your machine doesn't have a sacrifice sheet, then you can attach a temporary one by clamping a piece of MDF down. An alternate method that you could also use is to create a corner jig, and just ensure that you can pre-size your material very accurately, and you can set your XY0 to the corner of that jig very accurately too. And so this method, when done correctly, will give you an excellent alignment in X and Y. And so there are many strategies that you could use to approach two-sided machining on your CNC that you could explore. And I'm going to show you this symmetrical dowel method in the next example. And so the file that we're going to look at now to demonstrate a two-sided project in the software is based on one of the free monthly project files called Cool Cubes. And the file that I'm going to work with is an edited file which you will have access to in the project folder. So we're going to look at creating a version of one of the boxes. Now these boxes are designed in a way that we can cut the decorative elements on one side of the material and a series of pockets on the other side that will enable us to assemble and join them together to create the box. So let's go in the software to set up our part. So in the software we're going to open an existing file. So in the Introduction to Two-Sided Machining project folder, we're going to open the Cool Cubes edit file. Use the open button to do that. So here we're just looking at the overall design here for one of the Cool Cube boxes. So we've got a box with 4 sides. So we've got 2 side panels, we've got a rear panel and a front panel, and then we have a top part. So the bottom part, we're actually going to cut that separately as that's just a simple square shape. Okay, so everything that I'm highlighting now represents the decoration of the box. So all of the highlighted vectors represent the top side of the part that we're going to cut out. And then all of the rectangular vectors that you can see here, we're going to pocket them out in order for the box to join together like we saw in the slide earlier. So they'd be cut on the other side. Then we have a dowel hole location either side. So we've got a symmetrical pattern here where we'd look at drilling all the way through our material and into our spoil board. And then we've just got some text at the bottom. This is just telling us what each part represents. We've got the side panels, rear panel, front panel, and the top part. And so this file that we've opened was originally saved from a single-sided session. Now, as we are creating a two-sided part, we need to create a two-sided environment. So to do that, we first off need to go over to our job setup form. So we can see currently this is set as a single-sided job. In this case we want to use the double-sided option. And you'll notice that now that I've clicked that, we're presented with a few extra things within our form, and we'll talk about those shortly. Next up, we want to check over the job size. So we're going with a width of 24, height of 5.5 and a thickness of 1/2 inch in there. And then we move on to the Z0 position. So now that we are setting up a double-sided part, we must set the Z0 position for both sides of our material. Okay, so here you'll notice we've got 2 graphics. So we need to set up the Z0 position for the top side, which is the graphic on the left, and we also need to set the Z0 position for the bottom side, which is the graphic on the right. Where you see the number 1, that indicates the top side. Where you see the number 2, that indicates the bottom side. And so we just need to indicate where we want to set our Z0 position for the both sides. We can do both sides on the material surface. So on the top side it will be on the material surface, and then we flip the material over for the bottom side. We'll also set that to the material surface, or you could do it the opposite way around, where for the top side you could set that off the machine bed, and when you flip the material over you're also going to set the Z0 position off the machine bed here as well for the bottom side. Alternatively, you could look at zeroing off the same side. So if you check that option, that will always reference the Z0 from the same face of the material. So here we can see that now on the top side of our material we're referencing our Z0 from the material surface, but for the bottom side we're actually going to reference that from the machine bed, and I prefer to set the Z0 off the same side, where the top side is on the material surface, the bottom side is on the machine bed, and this way it just ensures that the Z is always referenced from the same face of your material. Then you need to set your XY datum position. So in this case, we're going to go with the lower left-hand corner. I can see that's indicated in the graphic here, and I can also see that indicated with this red square at our X0, Y0 in the lower left of our job. So the next criteria in the form is to specify the flip direction between the sides, where we can flip this horizontally or we could flip that vertically. And it doesn't matter which one you choose, you just need to remember how to replicate this virtual setup for when we physically flip the material over on our CNC. In this case, we'll just go with this option here, and then we could go ahead and press OK. So you'll notice now that I have additional icons at the top of my user interface, which are all relative to the two-sided setup. And we're going to talk about what each one of these represents. I'm just going to click on this icon here just to switch this option off for the time being, and we'll come to look at what this is shortly. Over to the left, we take a look at this icon here. So this icon represents the direction that I chose to flip my material in the job setup form, where we chose to flip this horizontally. I can't actually click on this item, but it's just there as an indicator to remind me which way I chose to flip my material. And so it's useful having that there as a reminder. And if I did want to change the flip direction, I can do that by going back into the job setup form. And then I can choose to flip that vertically, press OK, and you'll see it, the icon here has updated there. Now in this case, I actually want to flip my part horizontally, so I'm going to go back into the job setup form and select this option here, press OK, and again you can see it, that's updated. Then we have this button here, and this button is a toggle button which enables us to flip between the top and the bottom side. At the moment we can see that there is an arrow pointing down onto a block of material. And that's an indicator for me to tell me that we are looking and working with the top side of our material block. And if I click on that, you'll see now that we have an arrow pointing up to the material, and that's telling me that we are looking and working with the bottom side of our material. You may also notice that the rules have changed colour, and this is just another indication to remind me that I'm working on the bottom side. Now not only can I switch sides by using this icon here, but I can make use of the keyboard shortcuts, where 1 will take me to the top side and the number 2 will take me to the bottom. So 1 back to the top there. And so at the moment, all of the vectors are currently on the top side of our job. I also have an additional icon over here in the view toolbar, and that enables me to work in a multi-sided view. Now this will enable me to see vectors that I may have on the other side in the 2D view. It also allows me to see 3D information in the 3D view. For example, when I simulate toolpaths for both the top and the bottom side, I'm able to look at both sides in the 3D view. So if we click on that to turn that on, we can see that the icon has actually changed, okay, and it's currently highlighted. Not only can I just click on this to toggle between the single-sided and double-sided view, but I could also use the keyboard shortcut, which is the equals key, okay, so I've just clicked that there, that's put it back into single-sided, and if I click on that again, that's going to put that back into a multi-sided view. And so we can see here that we haven't seen much of a change in terms of what we can see, and that's because we don't have any data on the other side. So now if we switch over to the bottom side, you can see now that with the multi-sided view switched on, I can view the vectors on the other side as if I was looking through the material. And so these vectors that I can see on the other side are a light green colour. I can't select them or edit them on this side, I can just see them. So we can see that the text is now reversed and the top panel is now on the left hand side, and that's because we are flipping the part horizontally. So this is very useful, having the ability to see the opposite side's data in terms of where I create new vectors relative to the vectors on the other side. And a very handy feature here is that I'm able to snap to geometry that exists on the other side too. For example, let's go and draw a rectangle. So here I can snap to the points on the other side of our job, like so, and so you can see how easy that is to do. And then if I come over to the multi-sided view and just toggle that off, you'll see that I just have the new vectors that I created that were aligned to the vectors on the top side, and I can no longer see the vectors that are on the other side because we're in a single-sided view. So let's just take those vectors and we'll just go ahead and delete them. And then we're just going to switch the multi-sided view back on, as this is very useful for me to see all of the information in one session. So let's switch back to the top side. Now I don't need to create any vectors in this example. I have all of the vectors that I need to create the box. I just need to organise them into their sides. So that's what we're going to do now. We're going to look at taking all of the decorative elements of the box along with the profile cutouts, and we're going to move them to the other side. Okay, so to do that, we're just going to select the vectors by dragging a box up to the top left location, and anything that touches this selection box will be selected. So you can see I've got the decorative part along with the outline that I need to cut the part out. Holding down Shift, I'm just going to do that over here as well, like so, and again for the rear panel, click and drag for the front panel, and then we'll just take everything here for the top side. And so then what we can do is we can now move them over to the other side. And so to do that, we right click, and at the bottom here, you'll see we have the option here to move to the other side. And so we can see that with multi-sided view switched on, I can see that the software has accurately aligned the vectors onto the other side based on the flip direction. And again, having the multi-sided view switched on is extremely useful for us to be able to better visualize the overall part in a two-sided environment. So let's just go ahead and switch over to the other side, and you can see that those vectors have been moved over. Now, one thing that I want to point out here is that we are using the symmetrical Dowel method, so that when we flip between each side, you'll notice that the dowel positions do not move. And that's because they're symmetrical. And when we flip the material over, we're going to have the correct alignment in X and Y. So now I want to run through how I plan to cut the whole part. So in terms of machining, I plan to cut these vectors using the pocket toolpath so that we can assemble all of the panels to form the box. Then we're going to look at taking this vector here along with this vector here, and we're going to machine the dowel holes all the way through the material and into the spoil board. And that's all of the toolpaths for the top side. We'll then take the material off, and then we'll insert the dowels into the holes in the spoil board, where we'll then look at flipping the material over in this direction, and then position the material onto the dowels to align the X0 and Y0, and then secure the material down in place, and then we're ready to machine the toolpaths for the bottom side, where we'll look at profiling the decorative holes, and then finally look at profiling all of the outlines to cut each of the parts out. So let's go and run the toolpaths. So we're going to go over to the top side, and then using this icon here, we're going to switch out from the design commands over to the toolpath commands. Okay, we've got another useful reminder here telling us which side we are creating our toolpaths on. We can see it says top there. Now, as ever, what we should do before we go ahead and create any toolpaths is check over your material setup. So material thickness we're working with is 1/2 inch. We're going to set the XY datum position in the lower left hand corner, and we're going to set our Z0 on the material surface for the top side. Okay, so another reminder there that we're on the top side. So material surface for the top, check over your rapid Z gaps above the material, your plunge and your clearance is safe and appropriate, and your home and start position and the Z gap above your material is also safe for your own setup, and then you could go ahead and press OK. So we're going to first look at creating pocket toolpaths for these vectors that I'm selecting here. So with those selected, let's go over into the pocket toolpath. First off, we need to specify a start depth. So here we're going to go 0, and then we need to specify a cut depth. So in this case, I want to cut down 1/8 of an inch. So we'll just type that value in there. Next up, we need to choose a tool that we want to use. So we're going to use the select option here. That's going to open up the tool database, in which case I'd like to use a 1/4 inch end mill in here. Check over the settings, ensuring that they're safe and appropriate. Then we could go ahead and press select. Then we could choose how we clear that pocket, whether we do that in an offset strategy or a raster strategy. Now, as we're working with horizontal pockets here, we want to go in a raster strategy where we're doing that parallel to the x-axis. So I'm going to make sure that the raster angle remains at 0 there. Then we could give that a name, so we're just going to call that one pocket 1, press calculate, and so that will automatically open up the preview toolpaths form, and we can see the toolpaths displayed there, and then we could go ahead and preview that and simulate that in our block of material. Okay, so that's good. So we'll put that back in Z, and then we'll close out, and then we'll just tile the windows horizontally. Now this time we want to select all of the vertical rectangles here, and again we're going to look at using the pocket toolpath. This time we're just going to cut a little bit deeper. So with those vectors, let's go into the pocket toolpath, and so here we're going to go with a cut depth of 1/4 of an inch this time. The tool, we're going to use the same tool, so 1/4 inch end mill, select that. We're going to raster this, however this time because we're working with vertical vectors, we're going to change the angle so it's parallel to the y-axis, and so we're going to do that at an angle of 90 degrees. We'll just call that one pocket 2, and then we can calculate that. Okay, so you can see the preview there, and then if we go ahead and actually simulate that toolpath, we're able to see what the part will look like. Okay, and so you can see that that is a little deeper, and that will help us assemble all of the panels to create that box. Right then, so let's just put that back in Z. And so now we'll close out the preview toolpaths form. We're going to look at creating the dowel holes using this vector here, and if I hold down shift we can select this vector here. So with those vectors selected, let's come over into the drilling toolpath. So here we're going to look at cutting all the way through our material and into the spoil board. Now we know that our material thickness is 1/2 inch, okay? So we're going to make sure we clear that. We're also going to go 1/2 inch into the spoil board. And so we're going to do a total cut depth here of 1 inch. And we need to select a tool from the tool database. In this case, again, we're just going to go with the 1/4 inch end mill, and then we could go ahead and press select. And then here, we'll just give that a name. So we're just going to call this one dowel holes. And then we could calculate that. And the software is warning us that we are going to cut into the spoil board. We're going past our material thickness, which is okay because we've told it to. This is what we intend to do. So we're just going to go ahead and press OK there. And then we could go ahead and preview that toolpath, and we can see we have a hole over here and we have a hole over here. And so in reality, after we've machined these 3 toolpaths, we'll take our material off of our machine bed, and we'll take the 2 dowels and we'd locate them into the holes that have been left in the spoil board from when we drilled through our material and into the board. and then we'd take our material that we've already cut into and would flip that over, ensuring that we're flipping that over in the same direction that we've set that in the software. So in this example, we're going horizontally here, and then we'd secure that in place to the dowel holes, and that way we know that our XY coordinates are going to be aligned with each other on the top and the bottom sides. And then now we could go and look at running the toolpaths for the bottom side. Okay, so at this stage we'll just go and switch over to the bottom side here, and then we'll close out of the preview toolpaths form. Again, you'll notice now the toolpaths being displayed here will be for the bottom side. And as always, we should always check over our material setup before we go and create any toolpaths. So again, we're just really glancing over, just making sure everything's safe. So our thickness is 1/2 inch, XY lower left. The Z0 for the bottom side, we're doing this on the machine bed. Okay, so remember at the start I said that I prefer to set the Z0 off the same side, where the top side is on the material surface and the bottom side is on the machine bed. This way it just ensures that the Z is always referenced from the same face of your material. Check over the rapid Z gaps, home and start position, and everything looks good, so we'll just go ahead and press OK. Okay, so we've got the warning here, so it's telling us that the tool will cut through the material, so that's the dowel holes. We're aware of that, so we're going to go and OK that. And so the first toolpath we're going to look at is a profile toolpath for all of the decorative holes. So I'm going to select all of the circle vectors just by dragging up and holding down Shift to create multiples in my selection, like so. And with those vectors, we're going to go over into the profile toolpath. So we're cutting down to 1/8 of an inch in this case. We're going to type that value in there. Then we use the select option here to select a tool from the tool database. In this case, I'd like to use a 1/4 inch ball nose. Check over the settings, ensuring they're safe and appropriate. Now we could go ahead and press select. Then we need to tell the software how we want to machine the vectors, whether we do that on the outside of the vectors, the inside of the vectors, or actually on the vectors themselves. In this case, we want to machine on the inside. Then we can give the toolpath a name. So here we could just call this one decorative holes, press calculate, and we can see the result of that there, and then we could go ahead and preview that toolpath. Okay, so that's a real interesting effect that we've got there. So now we could look at creating the cutout parts for all of these vectors that we've got that represent the side panels. So let's close out, and then here we're just going to drag a box that's touching all of the vectors that I need, and then we could go over into the profile toolpath. Okay, so this time we're going to cut all the way through the material. So a top tip here is you can enter Z followed by the equals key, and the software will auto fill that information based on the Z setting that you put in the job setup form for the thickness of the material, and you'll see it's entered 1/2 an inch in there. Then we need to select a tool, so we use the select option here. We're going to use the 1/4 inch end mill, and then we could go ahead and press select. This time we're going to machine on the outside of the vectors, so we're going to use the outside option here. Okay, so I'd like to add tabs to this toolpath, so we're going to check that option there. And so the software has remembered the position of the tabs that were originally in the single-sided file. And I'm happy with these, so we're just going to leave those as they are. So then we could just give that a name, and we're just going to call this one Profile Cutout, and then we could go ahead and calculate that. We can see the path that it's going to take, and then we could simply go in there and preview that toolpath. And so there we go, we can have a look at that. We can also twiddle that around, and we can still preview the toolpaths that we've created on the bottom side over here. And so it's very important that your part looks correct at this stage, as the toolpath preview shows you an accurate representation of what we would see on our CNC machine if we was going to go ahead and run these toolpaths. So if something doesn't look as you wanted it here at this stage, you can go back and make edits to the toolpaths, recalculate them until you are satisfied with the results that you see here in the toolpath preview. And that's what makes the toolpath preview such a powerful tool. So now that I'm confident with the preview here, we can see what both sides will look like. I can now think about going to save the toolpaths out in a format that my CNC machine will understand. So let's close out of the preview, then we'll switch over to the top side. And then we can go over to save the toolpaths out. So here we have the option to add side to the toolpath name, and this is just another safety feature in that when we save the toolpaths out, it's going to tell us what side this toolpath belongs to. So it's always good practice to actually check that option there. Okay, so you can see at the moment we've got the pocket end mill to be saved out. We're going to select an appropriate post processor from the list. Okay, so we've got many here. In this case, I'm going to go with the generic G code, and then we can use this option here to save out the toolpaths. So here you could give that a name. You'll see that it's put the word top in front of pocket 1, so I'm happy with that, so you could go ahead and save that, and then you do the same for the other toolpaths. You can close out, switch over to the bottom side into the save toolpath form. Again, check this option here to add side to the toolpath name, in which case we can then select the decorative holes toolpath. We can see it's listed here. We're using the 1/4 inch ball nose, use the same post processor, go ahead and press save, and you'll see that this time we're displayed with the word bottom in front of the decorative holes name. And we can save that, and then we'd know that that belongs to the bottom side. So you'd save out all the toolpaths, and then we'll just close out here. So now that I'm ready to go and run my toolpaths, I'm going to make use of one final feature in the software, and that's the ability to create a job sheet. And that basically details all of the important setup information for my part that I can then print out and take with me to my machine to ensure that I set up my part correctly. Now, the job setup sheet feature is for Pro and Aspire users only. So let's go over to the top side. Okay, so you can access the setup sheet here. And so if we click on that, that will tell us that we need to save out this HTML file, and it's already named it for us based on the name of our file. So here we could just go ahead and press save, and then we'll switch over to the bottom side and go into the create job sheet tool, and you'll see that our previous one for the top side is now listed here, and you'll see that it has the word top at the end, so now we can differentiate them. We know that that's the top one, and the one that we'll be saving out now will be the bottom one. And so when we go ahead and press save now, that will add that there. And so now if we bring up our Windows Explorer, you can see in the project folder we've got the summary for the top and we've got the summary for the bottom here. And if I double click on this, that will open up a window browser. Okay, so that's just going to open that up, and I can see that we've got the job layout at the top. We've got all of the vectors that represent the top side. We can see in our material setup, we're looking at the top side here where we're setting our Z0 off the top of the material with XY in the lower left hand corner. And then we can see the actual toolpaths listed here for this size. And if we exit out of that, we can open up the bottom HTML file. Here we displayed the vectors for the bottom. We've got the bottom side listed now. You can see the flip direction, so that's important to remember when you're at your CNC machine. And also where we're setting the Z0 for the bottom side, and on this side you'll remember that we're setting that from the bottom of the material, and here you're displayed the toolpaths for that side also. Okay then, and so that really completes this introduction tutorial for two-sided machining. So let's go ahead and save the file. So go to File, Save As, and then in the project folder we're going to call this one Introduction to Two-Sided Machining. Press Save and you can access that from there.